Hello everyone, my name is Urbaz. I work as a tutor at the Thomas Rivera Center here at UTSA. We're located on the second floor of the JPL in the Q Lab. Today's General Chemistry 1 topic is stoichiometry. So what they're basically telling us in this problem is that there's a main chemical reaction that's occurring between ethane gas C2H6 with chlorine gas Cl2 to produce chloroethane C2H4 C2H5Cl and HCl, and that there are other minor products that are formed that may reduce the yield. And so the first step in a question like this is to go ahead and write down the main chemical reaction, the one that we're interested in, and then go ahead and balance it. And so in this case, the reaction as shown is already balanced, but in other cases, you would have to make sure that it's balanced before you start. The second step in the problem like this is to go ahead and write down the known information. So we had 300 grams of ethane reacting with 650 grams of chlorine to produce 490 grams of the chloroethane. So now the concept of limiting reactant and theoretical yield and actual yield come into place. So the question actually asks for the percent yield of the chloroethane. Percent yield takes into account the actual yield and the theoretical yield and figures out how close the actual yield was to the theoretical yield. So it's a percentage of how good your yield was. And so the limiting reactant, whether it's ethane or chlorine gas, will dictate how much product is actually formed. And so if you just look at it straight off the bat, 300 grams and 650 grams, it's not right to just say that, oh, since 300 is lesser, that it might be the limiting reactant, because that will not be true. We have to compare everything in moles. And so that's why we're going to have to do dimensional analysis so that we can convert everything to moles using their molar mass, and then do mole-to-mole ratios, and thus figure out what the limiting reactant will be, and that will tell us what the theoretical yield will be. So here we set up a dimensional analysis, 300 grams of ethane, and so we put the grams of ethane down here so that we can cancel it out, and we're going to put moles of ethane up here, and 1 mole of ethane is 30.07 grams of ethane. And then now we're going to, so at this step, we can't stop here and just figure out what the moles of the reactant is, because now we have to do a mole-to-mole ratio with the reactant, ethane, and the moles of the product, chloroethane. And since this is in a 1:1 molar ratio, so the coefficients of the balanced chemical reaction will tell us the molar ratios, and so it's a 1:1 ratio. Because so now that we've figured out, we've canceled out the moles of reactants and figured out how many moles of product would hypothetically be produced if all of the ethane reacts. And so this will actually tell us the moles, which is 9.98. Moles of the chloroethane. Now we have to do the same thing with the other reactant, which is chlorine. So 650 grams of Cl2. We're going to do the same dimensional analysis, put grams of chlorine down here and moles of chlorine up there so we can cancel the grams out. 1 mole of Cl2 is 70.9 grams of Cl2. Now we're going to go ahead and put moles of Cl2 down here so we can cancel it out. And moles of the product, C2H5Cl, chloroethane up there. And this once again is in a 1:1 molar ratio. And if we calculate this, we get 9 0.17 moles of the chloroethane. And so at this point we stop and kind of trying to understand what we've done so far means. So this means that if we were to completely react, if 300 grams, let's say that ethane was hypothetically the limiting reactant, and if all 300 grams of ethane reacted, it would hypothetically produce 9.98 moles of the chloroethane. And now let's say if the chlorine gas was the limiting reactant, and hypothetically if all 650 grams of it reacted, then hypothetically 9.17 moles of the chloroethane would be produced. Now we have to compare and see which one of these two numbers is lesser. And since the 9.17 moles of chloroethane is lesser, it means that this is the only thing that's virtually possible. And so since this is the only possibility, this 9.17 moles of the chloroethane is considered our theoretical yield in moles. And since this was the theoretical yield in moles, the reactant that it came from, Cl2, this is considered our limiting reactant. So this is a process that has to be employed every time we're figuring out what the limiting reactant is and what the percent yield is. And so now that we know what the theoretical yield in mole is, we have to go ahead and figure out what the theoretical yield is in grams. So we're going to just go ahead and convert the moles of the C2H5Cl chloroethane into grams. So moles goes down there to cancel it out. Grams goes up here. 1 mole of chloroethane is equal to 64.51 grams of chloroethane. And if we go ahead and calculate this, we get 591 grams chloroethane. So the moles cancel. And so now this right here is our theoretical yield in grams. And now we're going to compare this number here with this number right here, because this number is our actual yield. And as we predicted, the actual yield, 490, is lesser than the theoretical yield, which is 591. And it couldn't completely form 591 grams because, as the problem stated, there are other minor products that the amount of reactant is going towards. So now the final step is to calculate percent yield. Now we have everything we need to calculate this quantity. And so the percent yield formula is percent yield equals actual yield over theoretical yield, all multiplied by 100%. So we're going to go ahead and plug in the actual yield, as we saw, is 490. The theoretical yield is 591. Multiply this by 100%, and we get 82.9% yield. So this is the efficiency of this chemical reaction as performed in the lab, in this particular lab setting. So 82.9% yield. Again, it couldn't go to 100% yield because, as the problem stated, in an experimental setting there will always be side reactions or inefficiencies in the procedures, and this is what causes this error in the yield. So, anyways, this concludes our problem. Thank you so much for watching. If you have any further questions, be sure to visit us in the QLab. Our hours of operation are Monday through Thursday from 10 to 8, Friday from 10 to 4, and Sunday from 12 to 7. Be sure to like us on Facebook and like this video and subscribe to our channel. And thanks for watching.